Hello. So in this class, we'll do chapter 3.1 functions. So a relation, it pairs inputs with outputs. So when a relation is given as ordered pair, so x coordinate is the input and y coordinate is the output. So function is a relation that pairs each input with exactly one output. It has only one output. That relation is known as a function. So this is a relation given to us and we have to find if it is a function. So we know that first is input is x and output is y. And function is a relation that pairs each input with exactly and only one output. So we can see here this is input, this is output, this is input, this is output, this is input, output, input, and output, input, and output. So we can see that input is not repeated. Each input is paired exactly with one output. Input is not repeated. So that's why this is a function. So we have to see if this input has this relation is a function. So here we can say this is input, this is output, input, output, input. This 3 is input, minus 8 is output, 1 is input, negative 5 is output, and this is 3 is input and 6 is output. So we can see that the input 3 has two outputs, negative 8 and 6. So if for this to be for a relation to be a function, we should have every input should have only one output. So this is not a function. So in question 5, we can see these are the inputs and these are the outputs. And 0, when input is 0, it is negative 3. Output is negative 3. So is this a function? So we can see here that 0 has negative 3, 1 has input is 1, then output is 0. But when we can see that when input is 2, it has two outputs, 3 and 2. So input 2 has two outputs. So if any input has two outputs, it means it is for a relation to be a function, any input should have only one output. So this is not a function. So in question 6, if we see these are the inputs and these are the outputs, is this relation a function? So we can see that each input here is only associated only with one output. Okay. So here in this two was having, it was like 2, 3 and 2, 2. So each input, this input were associated, one input was associated with two outputs. Here, each input is associated with only one output. One output is associated with two inputs. So this is a function because each input has only one output. Like negative 10, it has only one output, 1. Negative 8 has only one output, 1. So we can also, so this is a function because each input has exactly one output. So whenever we solve these questions, if it is arrows going come like this, then we say not a function. Okay. And if it is like this, we say it is a function. So this is a function because each input has exactly one output. So this is a function because each input has one output. Okay. So now what we'll do is we'll see the graphs, and from the graphs we'll see if we can find if it is a function or not. So we can use, when a graph is given, we can use a vertical line test to see if the graph represents a function or not. So if it is a function, no vertical line passes through more than one point on the graph. So we can see this graph. If we draw the line here, or we draw line here, or we draw line here, then it passes through only one point. Basically it means that any axis associated with only one y. So this is a function. Whereas in this graph, here we can see if we draw a line, an x, one x has two y's. Okay. So it passes through 2 points, basically. So a vertical line passes through more than one point. We can have the graph like this also. So this is also not a function because here one x is associated with three y's like this. This is this is one x. Suppose its value is 1, or we can say 2. And this 2, when x is 2, it has three values of y. So this is not a function. This is also not a function because because one x is associated with two y's, or so if any graph is given, we can just try drawing the vertical line. If any vertical line at any point passes through 2 points, then we say it is not a function. If it passes through only one point, then we can say that it is a function. So domain of a function is set of all possible input values or x values, we can say here. And range of a function is set of all possible output values, that is y values. Okay. So suppose the function is y is equal to 2x. So if we give x, input is x is equal to 4, y is 8. 2 times 4. Okay. Let's do some questions. So input values are independent variables and output values are dependent. They are dependent on the input. So this is a question given. The function y is equal to 25x plus 500. It represents your monthly rent y in dollars when you pay x days late. So we have to identify independent and dependent variable, and the domain is 0, 1, 2, 3, 4, 5, and then what is the range? So what does this function says? When x is 0 means if you pay the rent on time, the rent is 500. But if you pay 1 day late, it becomes 525. Okay. With every day late, it adds up to $25. And when you pay on time, rent is 500. So what is independent and dependent variable here? So it depends on how many days you are late. So that is independent. Okay. How many days? Because so the amount of your monthly rent Y depends on how many days late, which is X, it is when you pay. So Y is dependent. Okay. Y, the rent is dependent on X, which is number of days you are late. So independent is X, how many days you are late, and dependent is Y, the amount of your monthly rate. Okay. So now the question B is domain is given. It means how many days your late is given, and you have to find the range. Like you have to find the amount of your monthly rent. And this is of course a function because we can see that with any one x cannot have two y's here. So this is a table we draw. These are all domains, which is the input, and then y is equal to 25x plus 500. So this is the y which we will calculate, and this will be our range. So let's calculate these. So we see when the input is 0, we get 500, means if we are 0 days late, we to just pay 500. Then it keeps on increasing by $25 with each day we are late. And if we are 5 days late, then we have to pay $625. We have to pay 125 as a fine or penalty. So this is the range 500, 525, 550, 575, 600, and 620. Let's do one more problem. So these are the functions given, and we have to find domain and range. So this is a absolute value of x. So because any value can go into an absolute value function, domain is all real numbers because we can put any value inside a absolute value function. But only positive values and zero come out of an absolute value function. So a typical graph of absolute value, this is like this. So it keeps on going. So any value can go into absolute value function. So domain is all real numbers, but only positive values and zero come out of an absolute value. So range is y is greater than equal to 0. Okay, so domain is all real numbers and range is y is greater than equal to 0. Now for 41, we can see that, excuse me, yeah, we can see that any value can go into absolute value function again. So domain is all real numbers and any positive value will come out. Only positive values or zero will come out of the absolute value function. Okay. So only positive value will come out or zero. But then it is multiplied to negative. Okay. So opposite of this, it will give all the values negative or zero. It will be graph will be turned upside down like this. Okay. So domain will be all real numbers and range will be y is less than equal to 0. Okay. So for 41, y will be less than equal to 0 or range will be less than equal to 0 and domain will be all real numbers. In 42, again domain will be all real numbers because absolute value can take all the real numbers as an input. But this graph moves 6 units down. So it will be like this was 0 here. It moves 6 units down like this. Okay, this is -6. So domain is all real numbers and only positive numbers will come out of this absolute value. So this will be y will be greater than -6, greater than equal to -6. So for 42, we saw that domain is all real numbers and range is greater than equal to -6. It moves 6 units down. So this function subtracts 6 after taking the absolute value of the function. Now for 43, we see domain will be again all real numbers because any value can go into absolute value function. And for the absolute value function, only positive values and 0 come out of it. Then it is multiplied by negative. So it will have all the negative values like this we saw earlier. This will be negative x. But then it is moved 4 units up or 4 is added to it. Okay. So this moves, this is 4 minus x. So it moves 4 units up like this. So this is 4. Okay. So the range is less than, so this is 4. So these all are range values. Okay. So first it is multiplied by negative. So all values are negative. In this case here we can see, and then 4 is added to the 4 is added to negative absolute value of x. So all values are less than equal to 4. So the domain is all real numbers and the range is y is less than equal to 4. So we'll do more problems in the next class. Please continue practicing and please let me know if you have any difficulty. Thanks. We'll meet the next class and we'll do 3.2. Thank you.